you, which might seem like kind of like a science topic, or we're going to talk about beginning population density, might seem like a geography topic, but it is something that they would like us to teach you in geometry, so I'm going to show you some examples. Population density is the number of people per unit of area. This may be calculated for a county, city, country, another territory, or the entire world. To find the population density, all you have to do is divide the total population by the area. The total population divided by the area every time will give you the population density. Right? Every time. People over area. So take a look at example 1. It says, what is the population density of China? If the area of China is 5,795,162 square miles, and the population is 1,321,851,888 people. Okay. Just kind of use that concept. Population over area. What was our population? You don't have to say the whole number. What's an indicator that I know it's population? It's a big number. What word's written next to that big number? People. So what number has people? That's my population. That's what's going to go in the top. And then area is going to go in the bottom. And I know it's area because it's talking about square miles, square kilometers, square something. Right? So unit of measurement. That's going to go in the bottom. And then you just divide those numbers in your calculator. Literally the hardest part about this is we're dealing with big numbers, and we sometimes forget to write one. We'll forget a digit, and then we'll throw our whole answer off. So that's why, one, it's important to show your work. Okay? Because if you don't show the setup and you accidentally type something in your calculator wrong, you get absolutely no points for that problem because I don't see your setup. I don't know where that number came from. Okay? But if you show the setup, then but your answer doesn't match your setup, then I can just assume, oh, they just plug something in wrong, minus it. So they know what they're doing, they just type something in wrong. Okay? So show your setup. Okay? When we plug this in and round to the nearest whole number, what do we get? 228. I'm going to give you 228. How we would label this? The top part is people. So I abbreviate people, per. And the bottom, it was our area, which was in square miles. That's how I like to abbreviate. People per square miles. And again, sometimes it's not always in miles. Sometimes it's in kilometers. So just be aware. It might be feet. Be aware of your measurement. Done. That's all you have to do. Population divided by area. We take a look at the next example. Questions over that one? We take a look at our next example. Same thing. We want to find population and density of Canada. The area is 3,854,085 square miles, and the population is 33,056,500 people. Draw on your answer to the nearest whole number. Make your fraction. What's going to go in the top? Square miles or people? People. Population goes in the top. So go to where it's people. Write that number in the top. And double check to make sure you got every number written down. Double check with your calculator to make sure you typed in every single number. I'm guilty of it too. I just type fast and I forget something. Okay? So then that means the other number, which is our area, our square miles, goes in the bottom. And then you plug that in your calculator. When you plug that in your calculator and round to the nearest whole number, we get what? 9. And we would label it people per square mile. And which one's more dense? Canada or China? China. China has a more dense population because its population density is bigger. Meaning, if we made a box in each country, bunch of those 1 mile by 1 mile square boxes, okay, evenly distributed the population. In China, in each of those 1 mile by mile boxes, there'd be 228 people. In Canada, there'd only be 9 people. Okay, meaning there's a lot more people in a smaller space in China compared to Canada. There's a higher population density. Okay? More density. Questions over that? Okay. Other type of density is regular old density. You maybe talked about this in science class. Okay. Reason why we talk about it because it incorporates volume. So density, just regular old density, is the measurement of the amount of mass per unit of volume. Any solid object that is less dense than water floats. Okay. So the formula for density, P stands for density, is equal to mass over volume. You take the mass divided by the volume. Every time when you're just asked to find regular density. Okay. So make our fraction. We want to find the density of a cube of sugar weighing 11.2 grams and measuring 2 centimeters on each side. So we use that formula. Density is equal to mass over volume. What's going to go in the top of our fraction? What's the mass? I think, how much does it weigh? 11.2. Okay, it weighs 11.2. And I'm going to put grams just to help us with our labeling. Did it directly tell us what the volume of that cube of sugar is? Did it say the volume of the sugar is this? No. But we know we have a cube. So I'm going to draw a cube off to the side. I know I have a cube. And all the sides of the cube are the same because it's made up of squares. Each side has a measurement of 2. Everything measures 2. Okay? So we can use this to help us find the volume. Sometimes you're going to be told what the volume is. Sometimes you're going to have to find it. Okay? If we go to find the volume, a cube is a type of what? Prism. So the formula for volume of a prism is big B times H. So when we find the area of our base, I know my base, everything's a square. So what formula are we going to use to find the area of a square? Big times height on your formula sheet, though, it is base times. Just stay consistent. You're right if you're thinking that in your head. You're totally right. I just want to be consistent with the formula sheet. Okay. So, again, it's a cube. Everything you plug into this formula is 2. Okay? So the base of our base is 2. The height of our base is 2. So 2 times 2 is 4. That's our big B. Our H, the height of the entire prism, is what? 2. Everything is 2. All the dimensions are 2. So then when we plug this into our formula, the volume is big B times my height. And 4 times 2 is 8. So that's our volume. And we would label our volume centimeters cubed. Okay? So then you just simplify this in your calculator. What's 11.2 divided by 8? 1.4. So the density of a cube of sugar is 1.4. We would label it grams was in the top per centimeters cubed in the bottom. That's the density of a cube of sugar. With that weight. Questions over that? So sometimes you're not given the volume, you're just given dimensions, and you have to find the volume on your own, and then plug it into the formula. Okay? If we take a look at example 4, it says Jeremy wants to know the density of a rock in grams per cubic centimeter. The rock has a mass of 1.08 kilograms and a volume of 400 cubic centimeters. What is the density of a rock in grams per cubic centimeter? What's the issue here? Yeah, they gave us what it was, the rock was in kilograms, but we want to know what the density is of it in grams. So what do you think we're going to have to do? convert. Okay, we're going to have to convert our 1.08 kilograms to grams. Does anyone know how many grams are in 1 kilogram? What is it? 1,000. Okay, so we have to do what? Are we going to divide by 1,000 if we're going from a smaller unit, or multiply? Or multiply by 1,000, because grams are smaller, so there's going to be a lot more grams than there are kilograms. So we're going to make this number bigger because there's more grams, okay? Because they're smaller. So when we multiply, what's 1.08 times 1,000? Little trick, move that decimal point over 3 places. 1,000. 1, 2. You plug your calculator. Plug that in. What did we get? 1,008? 80. Okay, that's why I had third on 1,008. 1,008. So that's how many grams there are. Okay, so now we converted our mass. Now we can easily find the density, because the formula for density is mass over volume. We said our mass was what? Our new mass. I just found it. It's 1,080 grams over, what's our volume? 400. They told us what our volume is. We don't have to find it. We can just plug 400 in for V. And then that was centimeters cubed. So we plug that in our calculator. What is 1,080 divided by 400? 2.7. So there's 2.7 grams per cubic centimeter. That is the density of that rock. Okay. Questions over that? Sometimes they might ask you to convert. There are conversions on your formula sheet, so you will have them if you are asked. For some silly reason, they don't put kilograms to grams. So you have to remember that there are 1,000 grams in 1 kilogram. Okay? And then if we're going in reverse, if we're given grams and we want to know in kilograms, you do the opposite. You divide by. Questions over that?